Okay, so our first lesson for geometry, we'll be speaking about types of angles. So let's get going, guys. I know a lot of you know these types of angles, so we're just going to be going and practicing and revising what they actually mean. Okay, so first definition I'm going to get us started with is that of adjacent angles. Now, I know there's been a lot of confusion between adjacent and opposite angles. Okay, you guys seem to, I know it's a concept that might be a little bit confusing. So we're going to have a bit of a definition and some examples on the difference between the two. Okay, we're going to deal with opposite angles later on. For now, we're dealing with adjacent angles. So adjacent angles share a common side. That was horrible highlighting. Share a common side. That was a little bit better. A common arm, and they lie on either side of the arm. Okay. Great. So this is basically a common side means they share a vertex. What is a vertex, lovely people? What do we say, or what do we call a vertex? What's another word for a vertex? It's a corner. Thank you very much, Slindile. So when they say they share a common side, it means they're on the same side of the vertex. Okay, I'll clarify just now. But let's look at these angles we have here. I have 4 angles labeled 1, 2, 3, and 4. And we want to determine which of these are adjacent and which of these are not. So I'm going to start off with our angle 3 and 4 adjacent, according to this definition. Are angle 3 and 4 adjacent? What do we say? Are they adjacent? Look where angle 3 is and look where angle 4 is. And do you guys think these angles are adjacent to one another? Okay, we're all saying no, which means we understand this definition. If you look at angle 3 and 4, yes, they do share a common arm, which is this one that I'm highlighting in blue now. Okay, and they are on either side of the arm. Okay, 3 is on the left, 4 is on the right. So far, we're good. But look where the corners of these two angles are. The vertex for angle 4 is all the way up there, and for angle 3 is all the way down here. Does that mean they are adjacent? No, they are not adjacent because they do not share a common side. Are we with me? They do not share a corner. So if we've determined that angle 3 and 4 are not adjacent, can you guys give me one pair that you can see that you would say is adjacent? No, Alice, there was not. Okay. There was not. Okay, Entle, see, I'm working on the names. Entle has suggested that angle 1 and 3 are adjacent. Do we all agree in the chat? Let's hear. Would we say, do we agree that angle 1 and angle 3 are adjacent? Mavis says no. Which of the properties do not correlate or correspond with the definition of adjacent angles? Which one do you think it is, Maureen? They do not have a common arm. Nice, Maureen. Angle 1 has these two arms over here. Okay, there's the first pair of arms for angle 1. Angle 3 has these two over there. There is no line that I have highlighted in both green and yellow, which means they do not share a common arm. Do you see why they are not adjacent? And now that we've established that, can I have a pair that is adjacent? Nice. Nice, Maureen. Look at angle 1 and angle 2. Angle 1, angle 2. Firstly, they share a common arm, which is this one, which is between them here. That's first property, met. They are on either side of the arm. Second property, met. And they share a vertex on the same side. All right. So they are indeed adjacent. What is my second pair that is adjacent? Not only 1 and 2, but which other two are adjacent? 2 and 3. Good, Slindile. Good. I'm not sure why, Alice. I'm not sure why. Okay, guys, do we understand this? Let's now move on to the definition of complementary and supplementary angles. Okay, complementary angles are angles that add up to 90 degrees, and supplementary angles add up to 180 degrees. Now, can you guys give me an example where we have complementary angles? There are cases where we will have complementary angles. Can anyone think of it? Nice. A right angle. If I have two angles, there we go, that are adjacent within a right angle, then we will say those angles are complementary because they add up to 90 degrees. Okay. What about supplementary angles? I can think of two examples. The straight line, yes. But what else? There's one more thing that we are forgetting. So this is my straight line, first angle, second angle. They're next to each other. They're on a straight line. All right. And these angles will be supplementary. But what's one other example of supplementary angles? Yes, Senyani, and that's exactly what I was looking for. Angles in a triangle because they always add up to 180 degrees. Are we with me so far with adjacent, complementary, and supplementary angles? Can I have a thumbs up, thumbs down? Okay, so far everybody is with me. Okay. Now, we move on to the next type of angles that we will be using. So this is angles around a point, which is literally the reason we're going to use. There is another word for this though. Does anybody know what other word we use for this? Angles that go all the way around and add up to 360 degrees in brackets. Does anyone know? Yes, that would be a revolution. You guys are on fire. Now I see why you guys want to geometry so much. Okay, so these angles, if you look at them, they all share one vertex, which is right in the middle. And they go all the way around. And these angles will always add up to 360 degrees. But there is one more case where angles add up to 360 degrees. It's not in the case of a revolution though. But can anyone think when that is? In the quadrilaterals, which is coming up soon. Okay, those four-sided shapes, they all have angles that are up to, for instance, a rectangle. These angles, all four of them, will add up to 360 degrees. Okay, great. Now let's apply the angles around a point. Okay, I have this specific example. I know it's very easy for you guys, but we need to work on notation. What does that mean? It means we need to work on how we write our answers. I know you guys know the answers, but the way you guys write them sometimes is scary. So we have been given an angle of 128 degrees, and I want you guys to tell me what is the name of that angle using variables, or letters rather, not variables. I know it's 128 degrees, but how would you tell me the name of that angle? What do you think? I know we struggle with this. C with a copy, AB with a copy, angle AOB with no copy. Okay, you guys are sort of nice, Arian. That is what I was looking for. Okay, so this would be angle AOB. And why is there a copy on the O? Why is there a copy on the O and not on the B or the A? What do we think? Because that's where the angle is. Okay, that's where the actual angle is, where the two lines meet. So we need to learn how to write these angles properly. Please learn this, guys. Great. So angle AOB is equal to 128 degrees. Great. Now I have an angle A over here that we are working out. Firstly, before I move on, please take note that this notation is not random. You have to follow the two arms of the angle. So I started at A, O is what follows, and B. You cannot say angle A, B, O, okay, because that's not how it goes. There is no line connecting A and B. So you have to follow the actual correct order of this angle. Great. Now I have a small letter angle A, and I always have a problem when my learners use whichever letter for wherever. When we use the small letters, that is because we have given that angle a variable. Look at where A is, the small letter A. There it is over there. So I'm calling it A, okay? So that's when I use a small letter. But if I am notating or I'm using notations such as this, I'm going to use a capital A. So please take note of that. I cannot now say 128 degrees plus A. Are we with me? You need to use the correct notation. So 128 plus small letter A is equal to how much? How much would those two equal? 360 degrees. So how would we find A? Nice. So then A will be 360 minus 128 degrees. And my final answer for angle A is 232 degrees. Is this complete? Would you get all of your marks if you wrote this in a test for this question? No, yes. Leachilo and Alice, why do you say no? If you say no, it means something is missing. And what is that? Your reasons. Ah, you guys are just fabulous. So we always have a statement and half your marks. Okay, well, sometimes less than half, but you get the point, right? Are going to go towards the reason. What is my reason for this whole calculation over here? Angles around a point. Beautiful. Wonderful. Okay. So just take note of the notation. Take note of whether you're using a capital letter or a small letter. And don't forget your reason. Always. All right. Let's move on to the next part. This we already spoke about, okay? Adjacent angles on a straight line. Adjacent angles. It wouldn't be wrong, Seth. I mark it correct if you say a revolution. Okay, that would not be wrong at all, because that means it goes all the way around. Okay. Now, I just want to emphasize something over here. Okay, this is angle A. This is angle B and C and D. Adjacent angles add up to 180. So I want you to tell me which angles add up to 180. They are all on a straight line. Okay? But I want you guys to tell me which angles will add up to 180 degrees. And I'm doing this on purpose because it is something that confuses a lot of us. A and B, A and D, D and C, B and C. Okay, so D and A, just the two of them, will add up to an 80, and B and C will add up to an 80. Now, angles such as A and B will not add up to an 80. And why is that? Why would A and B not be valid for this type of question? What do we think? They are not adjacent. Thank you, Sinyani. Look here, guys. Adjacent. We just learned what adjacent angles mean. And if you look at A and B, firstly, they do not share a vertex. A's vertex is over there, B is over there. Secondly, they do not share an arm. The first one is there. The other one is over there. Okay, and third, they are not on either side of that arm. If they don't share one, then it can't be on opposite sides of that arm. So A and B, not adjacent. D and C, not adjacent. Do not fall into that trap. Okay, guys? Hopefully we understand. Now, let's see. We need to find X. Do we have enough information in this sketch or in this diagram to find X? Yes, we do. And that's because this little block over here means what? That angle is 90 degrees. Okay, so I'm going to write my statement. And I'm going to write my reason. All right. So in my statement, I always like to start where this whole theorem or concept starts, which means I know you guys like to skip steps and you go straight to 180 minus minus minus. I get it. But if you make a mistake in that step, guys, you will lose unnecessary marks. So I suggest you start always with the X plus the 29 plus the 90 is 180 because that is what the theorem says. Okay, and the reason for me saying this would be angles on a straight line. Then you can start adding like terms and doing inverse operations and all of that. Okay, you don't have to write 500 steps, but I really do recommend that you write this step so that if you make an adding mistake, for instance, in the next step, if you make an adding mistake, I can still see as the teacher that you knew what was going on and it is purely an adding mistake. Okay, right. So then I'm going to choose to add like terms here. So I'm going to add these guys before I do what Sinyane did. So x plus 119 is 180. So then x will be 180 minus 119. Therefore, x is 61 degrees. And as I said, if you lose, for instance, let's say you make a mistake there and you write 129. That's fine because in your first step, you'll still get that mark. Are we with me? So be careful of skipping steps because if you make a mistake, it's going to be trouble. Okay, guys. Let's move on to the next one. The next one is an explanation of another concept. What is this concept called? I know you guys saw it and you were immediately like, we know what that is. We've seen it before. What is it called, guys? It says when two lines intersect, we have two lines over here, there, and another one over there. The opposite angles are equal, meaning angle C will be equal to angle DA. Guys, Reciting alphabet is dangerous. I'm going to say C and D. A and C, as well as B and a D. Okay, and those are called vertically opposite angles. Nice, guys. Opposite angles. All right, not to be confused with adjacent angles. So in this specific sketch that I have over here, which two angles would you guys say are adjacent? Just give me any pair of two angles that you would say are adjacent. I have to draw this adjacent thing in so that you guys do not forget it. Okay, I see some people say C and B. And opposite would be C and A. Okay, so these ones are adjacent. They are next to each other. And these ones are opposite each other. If you look at where the vertex is, which is over there, A is that side, C is that side, opposite sides. All right, guys. I am going to, I like that Senyane because it means something clicked and you were like, oh, okay, that's wonderful. I'm going to skip the brain break and go right to my summary of what we've spoken about today. So we've spoken about adjacent angles, which I've spoken about over and over the whole lesson, but it's important that you understand the difference between these two. Adjacent angles next to each other. Vertically opposite angles opposite from each other, okay? And then we spoke about complementary angles, which are adding up to 90 degrees, and supplementary angles, which add up to 180 degrees. Now, for those who have been watching us write reasons in shorthand form and thinking, what? Where did they get this? I am going to make a little summary for you here. Okay, let's speak about adjacent angles. If I want to say angles that are next to each other on a straight line, you can just say adjacent angles on a straight line. All right. Vertically opposite angles, you can just say vert op angles. Okay. Is there any other ones you would like to know? Any other shorthand form that we used here? Angles around a point. Around a point. Please, guys, avoid being overly creative with these and just use the ones that are there. Okay, please. Otherwise, the teacher might not recognize what you are trying to say. All right, let's do this one. Then we'll go back up and do the brain break. Complementary and supplementary angles would be exactly that. So you say complementary angles and supplementary angles. Okay, so I added 2 for those of you who are taking screenshots. You're welcome, Slindile. Throughout this whole geometry chapter, we'll be providing each other with reasons, acceptable reasons to use in a paper without writing a paragraph. Okay, so I have a little sum over here. We need to find x, y, and z. I'm going to get started by writing statement and reason. Can we get started? Remember, you don't have to start in order of letters. Okay, you can start wherever. So where would we start? Nice, Senyani. Senyani says, I can see that x is vertically opposite 105 degrees. So you just say x is equal to 105 degrees. And your reason is vert op angles. Wonderful. X is sorted. Alice is doing the right things because Alice is starting where the sum starts. y plus 105 degrees is equal to 180 degrees. And my reason is adjacent angles on a straight line. Great. Now let's work this out. If my 105 goes to the other side, I have 180 degrees minus 105 degrees. Therefore, y is equal to 75 degrees. So we have x and we have y. In a paper, I used to do this. Once I find the values of angles, just write them down. Otherwise, especially when it gets complicated, which it will, okay? Otherwise, you can't see how to solve the last one. And in this case, we have many options, right? I see some of you have used angles on a straight line. Some of you have used vertically opposite angles. What's the last option that we can use to find Z? There's one last option beside vertically opposite angles and angles on a straight line. A revolution, or angles around a point. So you could say for the last one, my 105 degrees plus the other 105 degrees plus the 75. Yes, 75 plus Z is 360 degrees. And my reason is angles around a point. Do you guys see the importance of reasons as well in this case? There are 3 ways to find Z, right, for our case. Now, as a teacher, can you imagine having to mark a whole class's paper and everybody use different reasons and you can't tell what you guys use? Like, you have no idea who used what. So it will help for you guys to give me a reason. Like, as soon as you say angles around a point, that's what I look for. And I'm like, oh, okay, that's a valid reason. Okay, so 105 plus 105 would be 210 plus 75 is 285 plus Z is equal to 360. So then Z is equal to how much, guys? I know you guys have already worked it out. Therefore, Z is 75 degrees. And I'm going to scroll up and zoom out and have the first thumbs up, thumbs down, I think in a while. Can I have a thumbs up if you understand? And a thumbs down if there's something that is not quite clear. Do not be shy. Do not feel pressure that everyone is doing thumbs up. All right. Wonderful. Achilo even gave me a little celebration. Okay, let's go to our brain break. Is anyone willing to speak to me today for the brain break? I haven't heard you guys' voices in a very long time. Okay. Anybody willing to speak to me for the brain break? Nobody? Okay, I see a hand. I see 2 hands. Nope, it's just one. Okay, let's go back up to the brain break. First one, are you ready to rumble? Are you ready to rumble? Alice, is it Alice? I feel like I'm forgetting names again, guys. Alice? No?
Hello, ma'am.
There we go. You can unmute. Would you rather never shower again or never cut your nails again?
Never cut my nails because they'll break off. But a shower, dirt will always be there.
You smart, smart girl. Like, they'll break off. It's fine. They'll break off. It's okay.
Thank you, ma'am.
But I have to shower. Oh my goodness. I agree. I agree. I agree with you. I thought I was going to catch you guys out with that, but obviously not. Singyani, are you ready?
Hello, ma'am.
Hello. It's been so long since I heard you guys' voices, guys. I feel awesome. Singyani, would you rather be able to control the time or control the weather?
Oh, the weather.
Sengani, please tell me it's not because of your outfit.
Mom, I hate winter.
Okay.
I always get
Okay.
sick in winter.
Guys, I would say time. If something is due, I would just pause,
Oh yes.
rewind. If, guys, imagine waking up and feeling tired in the morning and you can just rewind it back to like night time and have another sleep. Guys, oh my gosh.
Yes, that makes sense.
See, look at us procrastinators coming together for something good. Slindile, are you ready?
Yes, ma'am.
Let's hear yours. Would you rather be locked in a room that has a swarm of bees or a friendly tiger?
Ooh, that's a really hard one.
The tiger's friendly.
No, I'd rather a swarm of bees because I don't like anything that's like carnivorous and all that.
Oh, it's friendly. It's not gonna eat you. He seems to. If not friend shaped, if what? If not friendly, why friend shaped?
I would understand if it's a cub, but then it's a whole tiger. No.
Yes, it's friendly, man. It just wants to hang out. Come on.
No, I'd rather be stung by bees.
I would never, guys. I'm terrified of bugs. I am terrified. I would take my chances with the tiger. I don't care. No worries, guys. I'm going with the tiger. Is there nobody else who wants to speak to me? I still have one more. One more person. No? There we go. Singane, welcome back. Singane, would you rather eat a dead spider or a
Ah,
live worm?
oh gosh. I'm a dead spider. I hate worms. They're so disgusting.
And it's still alive, guys. It was
Exactly. It's going to be moving in your mouth and
ah! Oh my gosh, I can't, guys. It's
yeah.
not poisonous. It's not poisonous. So we're not trying to kill you guys. But it's a
Mm,
spider though. Oh, but it's
uh,
a worm. Oh,
a worm is a whole another area in its own.
guys,
It's
imagine biting it and like the juices go.
so
I would actually lose it. I would actually lose it. I would lose it. Guys, someone in another class said, I would just put it in bread. Just cushion it with a slice of bread. And then I don't have to feel anything. You guys are so creative. I actually can't. Listen to Alice. You see, you have another one in your class. Tomato sauce would save a spider. Just drench it in a bunch of sauce and just. Oh my goodness. Oh my goodness. Anything is better than the worm, guys. I'll never choose the worm. I don't care what you guys say. I will never choose the worm. I'm sorry. It's still moving. Imagine, and then you feel it go. Nope. I would tap out. I'll be like, it's fine. It's okay. We don't have to do this. Okay. Let's move on. All right. We have time to do more. So we're going to do more. That's my second one. It's very similar to the previous one, which means we're going to get through it chop chop because you guys are you guys and you are smart and you are, yes. So long while you guys tell me where we are starting this time, I'm going to write my statement and reason. Alice, that is true, but why is it impractical to start there? Why is it impractical to start with X and Y and 90? What do you think? Can anybody help? Why would it be impractical to start there? Because we have two unknowns, right? Yes, Ziva. We would never be able to solve that. So it would just, we just leave it as X plus Y plus that, and that's it. Nice. There we go. We have one solution already. Look where Y is. Look where 49 is. So y is equal to 49 degrees because they are vertically opposite angles. Great. I saw Senyani say it's easier to start with Z. It is. How would we do that? How would we do that? Start with Z. And be careful, okay? Let's talk about vertically opposite angles. Z is not vertically opposite 90. It's vertically opposite x plus 90. Do you see these two arms where they are? Look. So if you're going to use vertically opposite, you have to take this whole x plus 90, but we don't know x yet. Okay, so, the next solution is correct. 49 plus z is equal to 180. Can I have my reasons? Leachile has given me a reason. Adjacent angles on a straight line. Beautiful. And then we're going to move our 49 over to the other side, which means we're going to be left with z is 180 degrees minus 49. And my solution for z is 131 degrees. Great. We have y and z. We're left with x. We're left with x. Oh, Ziva has given me a solution. Ziva says x plus 49 plus 90. We could have even started there, right? Look at this straight line here. I'm not even sure if that's the one Ziva's talking about or the one with y. But there's one of them. We could have started there. X plus 49 degrees plus 90 degrees is 180 degrees. And my reason is adjacent angles on a straight line. I know you guys have worked out x. Can I see my answers for x so far while I add my like terms? This would be x plus 139 is 180, which means x is 180 minus 139. Therefore, what is my final answer, guys? Is equal to 41 degrees. Thank you, Alice Ziva. Okay, so the point of this is there are many ways to work out different angles. That's why we state the reason. What motivated my specific, method? Could you have said z is equal to 131 because of vertically opposite? If you found x before z, Silindile, then yes. Yes, you could have. Because remember I showed you where the vertically opposite angles are for z. So this whole x plus 90 over there is equal to this whole z over there. So it also depends which one you started with, right? If you started with x, you could have found z directly from there using vertically opposite, or you could have found y using adjacent angles on a straight line. But in this case, we happened to start with y. So the order in which you solve these doesn't matter, as long as you can find them and solve them. All right. Okay. Here's a nice, interesting one. How are we going to solve this guy over here? What do we think? Just give me the reason. I know the calculation is going to take a very long time to type. Nice. Nice, Alice. And what is my reason? I know that plus means equal by now because it's been messing with you the whole night. Alice is saying, Alice is saying, my English just tapped out, guys. My English just left the chat. Yeah. Alice is saying we are adding all of these. So x plus 30 degrees, which is the first angle, plus another x plus 40, which is my second angle, plus another 2x plus 10 equals 180 degrees. And what is my reason? Alice, I'm fighting with English today, so we're both fighting, okay? Oh, Ziva did give me a reason. This is adjacent angles on a straight line. Great. Okay, now let's get going. Like terms. I have x, 2x. What's x plus 2x? That's 4x indeed. And then we say 30 plus 40 plus 10. That would be, yes, so 4x plus 80 degrees is equal to 180 degrees. I'm going to get x on its own by moving my 80 degrees over. What happens when you move it over? It's equal to 180, nice singani, minus 80 degrees. So 4x is equal to 100 degrees. Now I still don't have x on its own because it's next to a 4. How am I going to get rid of that? Divide both sides by 4. Therefore, my x is equal to 25 degrees. Now, in this case, there was no specific instruction, right? So we all assumed it's solve for x. But you need to be careful with such questions because if I said to you, find the size of these angles, would we be done with our sum here? If my instruction was for you to find the sizes of all the angles, no, we would have to take 25 and do what with it? We would have to take 25 and substitute. Great. So my first angle, what would the size of my first angle be over here? X plus 30. First one is 55. Great. And my x plus 40 angle, this would be 65. And my 2x plus 10, that will be 60 degrees. Okay, so just make sure you read your question and see what they ask for. Great. I'm getting there. Okay, let's see what's going on here. How are we going to solve this one here? I have a 108 and a 2p plus 30 degrees. In this case, I just want you to find the value of p, so the variable. How would we solve this one here? Nice, vertically opposite angles. So you say 2p plus 30 degrees is equal to 108 degrees. And my reason is vert op angles. Then we do algebra. Remember when I told you guys in the beginning of the year that algebra is going to come back and haunt us? It's been coming back to haunt us, guys. It's not going anywhere. So the sooner we make friends with algebra, the better. And then 2p is equal to forever and ever and ever and ever. It's equal to 78 degrees. I'm going to divide both sides by 2 to get rid of it on my left-hand side. Therefore, my variable p is equal to 39 degrees. Great, you guys are moving very fast. We're flying now. Oh my goodness. Guys, please look at Alice roasting me. I'm actually I'm defeated now. 2b is equal to forever. Ever and ever and ever. It's okay, Alice. It's okay. I see you. I see you. Okay, guys, let's move on. It's okay. All right. We only have 2 left. Great. Let's find our x there. Actually, I'm going to go with fastest fingers first. Let's see who can find, for the last 2, who can find the answer the quickest. Dum, dum, dum. Who can find our answer the quickest, guys? This is my first one. Oh, Ziba has a 95. Okay. Let's see if these two are correct. Is it just two people? 3, 4. All right, let's see. I hope you guys remembered your reason. 45 degrees plus 40 degrees plus x is equal to 180. And my reason is angles are adjacent angles on a straight line. Great. And then I have 85 plus x is equal to 180. I move my 85 to the other side, which means it is now negative. So x is equal to 180 degrees minus 85 degrees. And in fact, indeed, x is equal to 95 degrees. Right. Wonderful. Are we ready for the last, final fastest fingers first? I hope you guys are waiting and ready. All right. Alice is like, just do it. There we go. And I want you guys to find y and to find that whole angle. So I'm expecting 2 answers in this case. Let's see. F is one. Thanks, guys. F was part of the... I'm going to go back. I'm going to go back to that question. Okay. Okay. It seems Lindile is the first one who wrote both answers in. 20 and 60. Let's see. So 30 degrees plus 3y is equal to 90 degrees. What was our reason for this one? I'm very curious to know. What was the reason for this one? It is indeed complementary angles. Nice. So then 3y is equal to 90 degrees minus 30 degrees. And my first answer, which is the whole angle, this whole angle, 3y is 60 degrees. But then I say work out y as well. So we're going to divide both sides by 3. Therefore, y is 20 degrees. Now, I want to go back to this guy over here. Guys, I warned you about capital letters and small letters, okay? What did I say about capital letters? We all thought we were solving F because we didn't look properly. Do you see? So in a test, you don't want to work out angles that you don't need because capital letters are notation for the lines. So if you were going to say angle BE, that was horrible. Angle BFC. I'm going to stop. You guys get the point. Angle BFC, then yes, you use the F, or angle AFB, or angle DFC. Okay, but the only ones that are part of the question are in small letters, guys. You must pay attention. Stop laughing at me. And that was a lovely, lovely lesson